Hi, everybody. This time we're going to talk about group 16 on the periodic table, sometimes referred to as the oxygen family. Now, we've been talking about trends, and last time we talked about group 17, the halogens, and now we're going to go one step further to the left. We're going to talk about the oxygen family, primarily oxygen and sulfur. We're talking about the reactivity trends of the nonmetals in this upper right-hand corner of the periodic table. Now, this is the second most reactive non-metal family on the periodic table. Just like their halogen cousins, these things are good bleaches and good disinfectants. But the group 16 elements are less reactive, meaning they're less good at bleaching and less severe disinfectants. So they're a lot less reactive than those halogens. Now, as you go down the family past oxygen and sulfur, you get to selenium and then tellurium, and then into the metalloids and then polonium. So this is a lovely collection of pictures. Oxygen, of course, is a transparent, clear gas that you and I are breathing right now. When you get it into a liquid state, it is a beautiful shade of blue. Sulfur in its pure solid form is a lovely yellow color. Selenium, tellurium both look like gray rocks, nothing terribly exciting. And polonium, the bottom of the family, is a highly radioactive element named by Madame Curie for her home country of Poland. So let's talk about oxygen. Oxygen, vital and important. 21% of the atmosphere of planet Earth is oxygen. About 79% of our atmosphere is nitrogen. Everything else, carbon dioxide, argon, and all the other trace elements, make up about less than or about 1% of everything else that's left there. So that 21% of the air that we breathe is in the state of O2, two oxygen atoms bonded together to make O2 gas that you and I are breathing in and out. Now, this is a relatively reactive chemical. It is made quite a bit less reactive because of the fact that these oxygens are bonded to each other. That stabilizes them quite a bit. But oxygen is a good disinfectant and a good bleach. So let's talk about where this is used. Hydrogen peroxide, H2O2, you and I use as a great disinfectant when we put it on a situation where there's blood. It bubbles, and that bubbling action releases oxygen. That oxygen gas actually is great at killing bacteria and fungus and things that might cause cause an infection in that wound. But this is less reactive than the halogens, and hence you don't want to put pure chlorine or fluorine on your fingers. That would be very hard on any sort of an injury. When we want to bleach things on our body, we tend to use oxygenating bleaches. Hydrogen peroxide, as a matter of fact, if you want to bleach your hair or you want to bleach your teeth, the whitening strips that are commonly used on teeth are hydrogen peroxide in a paste form. Peroxide that is used in every hair dye that there is some sort of a peroxide agent, even if you're dyeing your hair darker, to actually cause some lifting before they transfer the dye. All fabric bleach, whether that be an OxyClean, a Clorox 2, that sort of a bleach, those are oxygenating bleaches, and these are less reactive than chlorine bleach. So chlorine bleach, you have to be very careful where you use it. It works very well on whites, but we've all had situations where we've spilled chlorine bleach on something, ended up with white spots we didn't want. Oxygenating bleaches are great for all fabrics because they're less reactive. And why are they less reactive? Because they are further to the left on the periodic table, and it's a less reactive chemical. Group 16, underneath oxygen, oops, there's our picture right there. Underneath oxygen, we have sulfur. Now, as you go down the nonmetals, things become less reactive. Oxygen is more reactive than sulfur. Sulfur is an important compound chemical used in making rubber, but it is also a pretty good disinfectant. It is important as a fungicide, killing fungus, and it is a antibiotic that can be used in a lot of drugs for situations where you want something that is not terribly harsh. Urinary tract infection. So this is an antibacterial that you want to put inside of your body. Some skin disorders, eye infections, bronchial infections, pneumonia. There's a whole class of drugs that are sulfa drugs. And these sulfa drugs are using sulfur for their antibacterial properties. All of these things, these non-metals up here in this corner, are really good disinfectants. But because of the fact that they're further to the left and further down the periodic table, they're not as harsh as fluorine and chlorine and oxygen. Sulfur also is one of the primary ingredients in old-fashioned black powder or gunpowder. Potassium nitrate, sulfur, and charcoal were the original ingredients in gunpowder, important throughout the history, the last 1,000 years or so of the history of man. Now, we're not going to get into tellurium and some of those others because they're not terribly interesting elements. But let's talk about boron, because boron, I have just vaulted from way over here. I'm going to grab my eraser. Do I have my eraser? Aha, my eraser. I got to clean up my mess a little bit here. And let's take a look back at the elements. Now, we've been talking about oxygen and sulfur, and I'm going to go all the way over to group 13 to boron. Nonmetals get less reactive as you go to the left and less reactive as you go down. Now, these things in this corner, all good disinfectants. So let's talk about boron, way the heck over here. Boron can be used also to make a very mild antiseptic. What can it be used for? Well, this can be used for eye drops. When I was a child, I always had cats, I always had kittens, and they always had something going wrong with them. And I remember mixing up boric acid solutions to wipe out their eyes. If you are going to have an antiseptic for the eyes, this is a very delicate part of the body, so you have to have a very mild antiseptic. What that means is something that has a low chemical reactivity, and it still has the properties of that upper left-hand disinfectant non-metals, but it's so far to the left that it is relatively mild. Boron is a metalloid. It can be used in boric acid, as I mentioned, but it is also part of borosilicate glass, which is a fancy way of saying Pyrex. Pyrex, of course, is a brand name, and this is a glass that has been tempered. It is used because it doesn't expand and contract too much when it goes through rapid heating and cooling, and we can then put hot and very cold things into it. Borax also can be used boric acid can also be used to kill roaches, which, I don't know, sometimes not terribly fond of roaches, so that will work. That will do for our travels across the periodic table, and we will talk about other